Trig identity, we have to prove the left side is equal to the right. We'll start with the left, and mainly because it's probably going to be a little more complicated. We'll try to put everything in terms of sine. And since it's cosecant, we know that we can rewrite this as 1 over sine squared theta minus 1 divided by 1 over sine squared theta. So this is pretty confusing. We have a fraction divided by another fraction, and technically we're over 1. So I'm going to try to put this all as one whole fraction, and then we'll work on some fraction rules. So I'm going to expand this 1 into sine squared theta over sine squared theta, just so we have a common denominator. So we'll get 1 over sine squared theta minus sine squared theta over sine squared theta. All of that will be divided by 1 over sine squared theta. On top, we'll end up with our whole fraction. So 1 minus sine squared theta divided by sine squared theta divided by 1 over sine squared theta. Okay, so this looks really confusing.
Can we just cross out a bunch of stuff and say equals?
Well, what we can do here is let's actually turn this more into old school like elementary fractions. So this ends up being 1 over sine squared theta divided by sine squared theta. That was the numerator. Divided by, so we're going to write it this way, 1 over sine squared theta.
Oh, yeah, you flip it.
Exactly. So with our old fraction rules, this becomes a multiplication, and we invert our second fraction, and we get 1 minus sine squared theta over sine squared theta times sine squared theta, essentially. The over 1 won't really make a difference when we multiply across. So I'm going to come back over here. I'm not going to distribute this yet because I just want to see what will be important for us. We'll end up with sine squared theta times this bracket, 1 minus sine squared theta. And the denominator will just be 1 times that, which is essentially that value, sine squared theta. Now, what that means is we can kind of cancel out over here, the left and the right. Think of it like being the number 2. They eliminate into 1, and is that what the right side was? It's exactly what it was. So it works out perfectly. These two eliminate, and we end up with 1 minus sine squared theta. So in that one, it helped that we put everything in terms of sine. We also had to be decently strong with our multiplication and division rules. Probably a lot of addition formulas and double angle formula. So, you know, we were unsure what side should we work with, and it doesn't really matter. We'll choose one. If we get stuck, we'll go to the other and see if we can meet in the middle and then use that information to come back. So we'll focus on the right side to start. Our right side, our first double angle formula, we know that cos, I'm going to write it in green, cos x minus y is technically equal to, let's see if I write it out here, cos x times cos y plus sine x times sine y. So we can replace this with that information. And then our second one, I'll do it in blue, I guess. Another double angle formula, our cos x plus y would be equal to cos x times cos y minus sine x times sine y. So we'll replace those two to start. When we come down, I'm going to have to use the entire thing here because this is going to elongate quite a bit. We get cos x cos y plus sine x sine y. That's the first part. Subtract, are in blue here, cos x cos y minus sine x sine y. Okay, that negative tactically needs to be distributed to the two terms in there. So I'm going to write the rest in black here. Hopefully it's simplified a bit. Cos x, cos y, sine x, sine y, minus cos x, cos y, is that right? Yeah, plus sine x, sine y. Okay, if we take a look, this negative and this positive essentially cancel each other out. they disappear.
Mhm.
And the reason being, like, that's a negative and that's kind of like a positive one there. So they're gone. And then these two together will give us 2. Think of it like a coefficient of 1 in front. It'll actually give us 2 sine x sine y, which is actually exactly what our left side is. So that worked out much faster than I thought it would. Does this canceling make sense?
Yeah.
And does how we got 2 make sense or no?
Yeah.
Yeah. So we end up at 2 sine x sine y. Wow, that one went way faster than I thought it would.
Me too.